This lecture video is about an introduction to radicals. So you've probably seen radicals before. One example of a radical would be the square root of 9. And so this square root symbol is called a radical. And so the square root of 9 is equal to 3, and that's because 3 squared is equal to 9. And there's actually, when there isn't a number in this position of the radical, there's really an implied 2 there. And the square root and the squaring basically cancel each other out, giving you 3. One other little note that we're not going to spend a whole lot of time on, but whenever you have an even root and you're taking the square root of 9, this number is always positive. And so you could have gotten 9 underneath that square root from squaring a negative 3, or you could have gotten it from squaring a positive 3. So these would both give you exactly the same thing. They would give you the square root of 9, but it's always still just 3. So just remember that. And if you have the square root of something like x squared, and if they don't say anything about x, that x represents non-negative real numbers, then we would want to make sure that we put that x in an absolute value bar to ensure that when you take the square root of this, that it's a positive value and not a negative value. So again, I'm not going to talk about this all that much, but just be careful when you're doing your MyMathLab homework or a quiz, because if it doesn't make this statement a non-negative real number about the variables, then they'll want you to, whenever you do an even root of a variable, to make sure that it's in absolute value bars like that. Okay, so we're going to look at finding some square roots, and we are going to assume that all of the variables represent non-negative real numbers, so we won't have to worry about putting the absolute value bars around the variables. So our first example is a square root of 0.04, and this one you could actually do on your calculator, but it's 0.2. If you square 0.2, you'll get 0.04. Okay, so the square root of 0.04 is equal to 0.2, because if you square 0.2, you get 0.04. And square root of x squared, so again, remember there's an implied 2 here, and so you need 2 things being multiplied together underneath this root to get 1 out. And so the square root and the square basically cancel each other out, and this is just x. And again, if it doesn't have this statement, then you would need to remember to put this x in absolute value bars. We don't need to do that because x can't be negative anyways because of that statement. Square root of 16 is going to be 4, because 4 squared is 16. And then the square root of 10. So how many groups of 2 x's do we have underneath there? Well, you could write out 10 x's. And there's 1 group of 2, 2 groups of 2, 3, 4, 5 groups of 2, and so that would be x to the 5th. Basically, you can take your root, and remember there's an implied 2 here, and divide this power by your root, and you'll get the power of x that you'll need outside of the square root. Negative square root of 100, x to the 36. So 10 squared is 100. So it's going to be 10, and this negative sign is outside, so that's going to be carried down. And then to get the power of x, all you have to do is divide this 36 by 2, because remember this is a square root, so there's an implied 2 there. So that would be to the 18th power. Okay, so a couple more, and these are problems for you to do on your calculator. You may have a square root button right on your calculator, and it will depend on what brand of calculator you have. Some calculators you have to push the square root button first and then type in your number. Other calculators you type the number and then hit the square root symbol. It just depends on what kind of calculator you have. If you don't have a square up button on your calculator, you can type in 11 and then do what's called a caret symbol. It looks like a upside down capital V, and then put in your power, and we'll talk a little bit more about this later on, but the power when you have a square root is going to be 1/2. So if you want to do the square root of 11, you can type this into your calculator as well. Make sure that you put this fraction in parentheses. So let's find the square root of 11, and we'll round to 3 decimal places. And so when you do that, you should get 3.3166. And so that would round to 3.317. So because this number is bigger than 5, you need to round this 6 up to a 7. And the square root of 205. We get 14.3178. And since this is 5 or bigger, we need to round this 7 up to an 8. So it would be 14.318. So just be careful of what they're wanting on MyMathLab and how many decimal places they want you to round that to. Now we're going to look at some cubed roots. So now anything above a square root will have the root listed here. So this has got a little 3 that tells you that this is a cubed root. And so now we want to figure out what number can I multiply to itself 3 times to get 1 over 64. And so 1 times itself forever will remain 1. So really we just need to know what times itself 3 times will give you 64, and the answer to that is 4. So if you cube 1/4, you'll get 1/64th. And so that's why the cube root of 1/64th is 1/4. And the same thing applies for cubed roots or any other roots. When you're taking the cubed root of a power of a variable, you just take the power of the variable 6 and divide it by 3. And so that gives you x squared. Now we have the cubed root of negative 27x to the 9th, y to the 12th. And you can take the cubed root of a negative number, because you can multiply a negative thing to itself 3 times, and it will end up being negative. And it's 3 cubed is what gives you 27, so the cubed root of negative 27 is negative 3. And then for the variables, you take the power and divide by the root. And so 9 divided by 3 gives us x cubed. And 12 divided by 3 gives us 4, so that would be y to the 4th. Now we're going to take a look at nth roots, so that just means that there could be any roots. We have 4th roots and 5th roots in here. So a 4th root means that you would need to multiply something to itself 4 times. And so this negative sign is out in front, and the number that you can multiply to itself 4 times to get 81 is 3. And so the 4th root of 81 is 3, and it's actually negative 3 because of the negative sign in front of the root. Okay, and so here we have a negative sign underneath our 4th root, and whenever you have an even root, you cannot take an even root of a negative number. So this is not possible. Or better answer would be to say not a real number. Okay. And now we have the 5th root of negative 32x to the 20th. And so again, it's okay to take an odd root of a negative number, but not okay to take an even root of a negative number. So we need to figure out what number can I multiply to itself 5 times to get 32. And if you don't know what that is, then you can always factor 32. And so we'll just do that over here on the side. And so 32 is 2 times 16. And then you can keep factoring 16. It's 2 times 8. And then 8 is 2 times 4, and 4 is 2 times 2. So the bottoms of this tree, and you might factor in a different way, and that's okay, but the bottom of the tree, if you multiply all of those together, you'll get 32. And so we're multiplying 1, 2, 3, 4, 5 2's together. And so 32 is 2 to the 5th power. And that tells me that the 5th root of 32 would be 2. And it's negative because we have a negative sign underneath there. And remember, if you multiply an odd number of negative numbers together, you will end up with a negative result. So okay to take an odd root of a negative number, not okay to do it to an even root. And then do the same thing that we'd been doing before for powers of x. So we would take this 20 divided by 5, that gives us 4, and so the 5th root of x to the 20th is x to the 4th. Our next one here, 256, x to the 12th, y to the 8th. So we need to figure out what can I multiply to itself 4 times to get 256. So again, if you're not sure, go ahead and factor 256 out. And so 2 goes into 256 128 times. And 2 goes into 128 64 times. And 64 is 2 times 32, and we already know that 32, because we just factored that, is 2 to the 5th. And so we have 1, 2, 3, and then this is 5 2's being multiplied together, and so we have a total of 8. So that's 2 to the 8th. So we have the 4th root of 2 to the 8th, x to the 12th, and y to the 8th. And so you can do the same thing to this 2 that we've been doing to the variables. You can take this power, divide it by 4, and that will give you 2 squared. And then 12 divided by 4 is 3, so that would be x cubed. And 8 divided by 4 again is 2, so that would be y squared. And 2 squared is 4, so we get 4x cubed y squared. Our next one here, so whenever you have the division of two things underneath a square, you can actually separate this as the square root of y to the 10th divided by the square root of 9x to the 6th. Square root of y to the 10th, so remember when there isn't a root there, it's an implied 2, and so this would be y to the 5th, 10 divided by 2. And square root of 9 is 3, and then 6 divided by 2 is 3, so that would be x cubed. And our last one here, we have the cubed root of negative 8, a to the 21st, b to the 6th. And so the number that we could multiply to itself 3 times to get negative 8 would be negative 2. And a to the 21st, so divide 21 by 3, and we get a to the 7th. And then b to the 6th, we would divide the 6 by 3, and we get b squared. And that's the end of this lecture. So if you have any questions, let me know. Thanks.